Start. Okay, so we're here March 23rd. We're going to finish operator overloading today and start on templates. We'll see how far we get with templates. Tutorial 8 is due this weekend. So for tutorial 8 and assignment 4, when you're doing the parts classes, so I don't want anybody to get hung up on this for hours and hours and not be able to figure it out, but so you need to have destructors, virtual destructors. You can leave them empty, but they have to be there. Otherwise, when you delete polymorphically, you get undefined behavior. So it could be a seg fault, or you could get some weird crash or whatever. So yeah, just put that out there for you guys. Yeah, what else? Oh yeah, office hours. So I missed my office hours yesterday. I had, yeah, well, I mean, I don't want to do too much information here, but so I have a wisdom tooth that's giving me trouble, and I was incapacitated at the time. So I'll probably reschedule it for Friday, I think. And then, yeah. So I'll let you guys know the details of that. All right. Any questions on the schedule? All right. Yeah, we're coming up to so this is second class for us. So we have 1, 2, 3, 4, 5 classes left. Just a little over. Wow, crazy. Is the 11th the last class? Yes, that is the last class for this class. Might be a short one, but yeah. All right, let's get rid of my face. Okay, so last class we were talking about not templates, but we were talking about operators. In particular, we were talking about what was number 6? Oh yeah, we were overloading. For some reason, I don't think this example quite matches up with my slides. For some reason, I messed up, I think, somewhere there. But we were overloading the plus equals operator, and also we wanted to overload the assignment and the plus operator for our class time. So that's where we left off. And in fact, I think we left off right in the middle of the example, because so we left off with this, where which was actually a fortunate error, because we got to demonstrate how const can come, and be important to be used in the proper places. Because if I want to, for instance, send an R value to the output stream, right? So an expression will return an R value, then I have to make that const to guarantee that I'm not going to manipulate that or change it. Okay, so then let's just run through this example for posterity, and then we will continue on. So we made 2 times I go home at 13:15, and then you go home, which defaults to 0, 0. So we've already implemented the plus equals operator. So we can print out I go home, which prints out 13:15, of course. And then you go home is midnight plus 3,700 seconds, which is 1 hour, 1 minute, and 40 seconds, which is what we got here. And then we can also, so the thing about, we overloaded the plus operator, and the thing about the plus operator that is, I guess, slightly different from other operators is that when we enable cascading with the plus operator, we are creating a new temporary object and returning it, instead of modifying the original object and returning this. So if we look at our time class, this is the plus equals operator. And so we return a copy of the object. Well, not a copy, but a reference to the object. Whereas with the plus operator, we make this temporary time object and then return that. And what happens is, of course, this is on the stack. So it's going to get deleted. but the copy constructor will be invoked here if we assign it to another time variable. All right, so yeah. However, that gets returned as an R value, which means that we have to make it const. But the plus, so here we're returning some temporary time object that gives us a time of 1:40, but the original time object was not changed. So you go home is still midnight. All right. So that was that, where we left off. Now what we want to do here is implement the assignment operator. Well, look at this, because it seems like the compiler is not complaining at all, even though we don't have an assignment operator. Right, so we did not implement one yet. So what happens is, that's where we talked about before, the explicit and implicit operator overloading. So we get this implicitly, right? So the assignment operator, we get a default one, and it does a member-wise assignment. So what does that mean? Well, it just copies hours, minutes, and seconds from one time object to the other. And since these are all primitives, there's no dynamic, or sorry, not just primitives, but these are statically allocated. There's no dynamic memory here. That means that the default assignment operator is going to work just fine. So if we actually go back here, if we print out, so now you go home should be, what does I go home? 13:15. So you go home should be about, well, it should be exactly 1 hour, 1 minute, and 40 seconds after I go home. Right, so I go home after 13:15, you go home 1 hour, 1 minute, and 40 seconds after that, which is sort of exactly the behavior we want. So this returns a temporary object. That temporary object has its variables, member variables copied into you go home, and then we can print it out. So we get that for free. Of course, if we had dynamic memory in our time object, we would want to overload the assignment operator. So we're going to, yeah, well, any questions on this part so far? Okay. So what we're going to do, the other thing we want to do actually is something like this. So we want to enable chaining, and this actually, for some reason, the compiler does not complain about this, which I find kind of interesting. So I can assign, we want to be able to do something like this, right? We want to enable chaining with this assignment operator. And also, it might be nice to use the assignment operator to say, well, you know, I go home is 3,700 equal to 3,700 seconds or whatever. When we implement that, so that there's no error being thrown there, and there's no error here. However, it doesn't work quite the way we want it to. We're getting zeros here. I find it interesting that this did not give an error. But anyway, what we want is actually this to do something useful, right? We want to be able to overload this. We're going to overload this assignment operator for ints. So what we will do, we want to enable chaining with this. So again, we'll return a time reference equals and an int. Now I can't make this const because I am actually making changes to this time object. So this would be the function signature for that. And then here, okay, so we will assign it the value I, and that should be simple enough. We'll use our set time function. That's our private helper function that converts seconds to some time, right? So where is it? Yeah, this is our set time function that takes a int, that is the number of seconds, and converts it into hours, minutes, and seconds. So that's basically how we want our assignment operator to work. And then, of course, we have to return a reference to the current object to enable chaining. All right, so now when we do our assignment operation, this assignment operator is working with a time object and an int. We just defined it, so this should actually convert this time to 140, and then it should assign the same value to you go home if we've done everything correctly. All right, so I go home after 1:40, which is 3,700 seconds past midnight, and you go home after 1:40, which is just a member-wise copy from this guy to this guy. All right. So questions? Okay. So yes, the rule of three is, of course, if we had dynamic memory, we would overload the copy constructor, we would overload the destructor, and we would overload this assignment operator, but of course we would pass in a time reference. And that way we can make deep copies of our time object instead of shallow copies. But so that's, yeah, actually this should be a const. All right. Was that it for this? Yeah, I believe that's it for this. Okay. So any questions about this example? All righty. So just sort of review the plus equals operator. So we can make it deep copies. Yeah, you know what? Let's maybe a short demonstration of the rule of three here. Let's say that we wanted our seconds to be dynamic. This is going to, oh, it's fine. Let's make a separate one. Let's make bool. Let's do whatever. We'll add days, but we'll make it dynamic. So the rule of three states that, yeah, so this is dynamic memory. So in my constructor, I will say days equals new int, and maybe I don't know, whatever, 365. Okay, so we've dynamically allocated memory here. Now we have to, now it's a good idea, since we have dynamic memory, we have to implement a destructor because we want to delete it before we leave. So time. We want a copy constructor because we want to do a deep copy. So time reference. And we want to overload this assignment operator. That's the rule of three. And then so that we properly manage our memory. So then in our destructor, we would say delete days. In our copy constructor, we would say, we would do hours equals t dot, I guess I'll just go through it. Hours equals t dot hours. Minutes equals t dot minutes. Seconds equals t dot seconds. And days equals new int t dot days dereferenced. Yeah, so that way, you know, we make a copy of this this integer value, and then Yeah, and then in our assignment operator, we would do essentially the same thing we did in our copy constructor. Yeah. So yeah, that returns a reference, time and time. Yeah, so that's the rule of three. And now all of our memory behaves the way it should, right? So every time we do a copy, we make a deep copy, whether or not it's using the assignment operator, that's a deep copy, or the copy constructor, which is here. Exactly the same thing, except this is, of course, a brand new object. The assignment operator is working on a pre-existing object. But that's the rule of three. Copy constructor, destructor, and assignment operator. If you need one, you probably need all three. All right. Other questions? All right. Okay, so again, the plus equals operator, which we did not get into. We did that last class, but that was here. We return a reference to the time object. So we add the whatever this number is to the current object and return to this. So we turn a reference to the changed time object. So for assignment 4, we should make copy constructors, even if it doesn't list that. You do not have to do it if there's no dynamic memory. So if you only statically allocate, so if you don't use the word new in your constructor, then you do not need a copy constructor. You definitely need it. If you use the word new in your constructor, you definitely need a destructor. I don't think I'm not really going to enforce the copy constructor, but it would be a good idea. And I'm trying to remember all the details of assignment 4. Sorry, it just I can't remember what I asked you to do exactly, but I mean, it couldn't hurt. If you make your own copy constructor, you will definitely not lose marks. So that's probably the best way to put it. If I didn't list them, then probably you don't need them. I would have to double check to be sure. And especially if there's no instance where you're making copies of those things, copy constructors was sort of an assignment 2 thing. So yeah, again, this is the rule of 3 is more for, if you get a job programming in C++, people are going to mention the rule of 3. You should understand what it is, essentially. Yeah. Again, sorry. I mean, I can double check that and clarify for you, but off the top of my head, I don't think I enforce copy constructors. But if there's dynamic memory, then you definitely need destructors. All right. Other questions? Okay. So this returns a reference to the changed time object, whereas when we overloaded the addition operator, we make a new temporary object and then return that. Sorry. So we want to return some time object that represents, this time plus this int time, but we don't want to make changes to the original time object. So we don't return an int. This, technically we might consider returning an int, but if we wanted something like this to work, then we would want to return a time object. So, a time object is it makes more sense in this context. Okay, so operators on collection classes. So We can overload the subscript operator for accessing elements. We could do stuff like plus equals or plus or minus equals. So maybe, I could add two vectors together by using the plus equals. Possibly that's already overloaded for the vector class. I wanted to say probably, but I don't know for sure. Definitely double equals and not equals. You can compare two collections. Now this is, however, it's not quite as straightforward as before. We have to compare every element in the collection, but we can definitely do that. So let's try this next example. Okay, so we have a book class. The outputs, the stream extraction, stream insertion operator. I always get those backwards. The stream insertion operator, we've overloaded that. And then we have a title and author. We have a assignment operator. So this would be, we don't technically need one except for except we're going to make copies slightly different. So we don't have dynamic memory here, but when we make a copy of a book, we're going to keep the original ID. So these IDs should be unique, even if I change some of the details of my book. So we're overloading the assignment operator and the not equals operator. That's just going to, well, we can look at the implementations. So the copy constructor, we actually copy the ID. Why didn't I do that for the assignment operator? Maybe I just forgot. Yeah, let's do that. Ugh. Formatting. Okay, so there, our assignment operator and our copy constructors really should do the same thing. The not equals, two books are equal if their title and their author are equal. Otherwise, they are not equal. And yeah, we printed out, yeah, we have the output stream. So let's just take a look at very quickly. We make 5 books here, and let's print out a couple of them. So we can do, of course, because we have operator overloading with chaining, we could do stuff like this. B5 and line. So we can send all of these books one after another to the output stream. Okay. All right, so that's why that was so long. So it does need to be 35. Okay, so Ender's Game, Dune, Foundation, Hitchhiker's Guide to the Galaxy, and So Long and Thanks for All the Fish. Yeah, and they're nicely spaced out using the set width operation. So the width was set to 35, and I believe that's the width of this this title. There's 35 characters there. Okay, so far so good. Now we want to make an array for books and have and then be able to implement an array, not a primitive array, but an array class. Let me just pull up. Okay, so what do we want to be able to do? We want to be able to make an array, book array, let's say. Want to be able to make a book array and perhaps initialize it with a value, which is the size of the book array. So, and we also want to be able to make a second book array without initializing the size. And then we want to be able to do stuff like this, assign these books to the locations in the array. So we're going to overload this subscript operator. And this assignment operator will come from the book class. Yeah, okay, so let's do that. All right, so we want a class called book array. Here, I'm just going to copy some of this stuff. So we want, yeah, we're going to overload the stream insertion operator. So we're going to have a, and again, probably pretty important to put the const there. So we want to overload that. We're going to have a constructor that takes a argument, which is the capacity. We want a destructor, and we want some place to store our books, and we want to keep in mind how many books we're storing. So we will have an array of books. All right, and then this is going to be, so we're going to, this is just a pointer, right? So we have not statically allocated array. We're going to dynamically allocate an array of book objects in this example. And then also we are going to overload yep, I will explain that in 1 second. We want to overload some of these operators. So we're going to overload the yes, the subscript operator. So this takes an index, right? So how we use it is, well, if we go back to the main, of course, it looks like this. When we overload it, this is the signature. You can also do stuff like const. So what happens is, yeah, why is this important to be const? Well, sometimes we do things, for instance, if we overloaded the plus operator. So that would we could return a new book array that is equal to you know, this book array plus whatever. So we're going to concatenate these two book arrays, right? We're going to make a new array that can contain all of the books from the current book array plus whatever is in this one. And we return, but since this is a plus operator, we would say something like, you know, book array. I meant to 3 equals a array 2 or array 1 plus array 2. So this array 1 plus array 2 is going to return an entirely new book array, but this is what's known as an R value. So when you return by value, it's an R value, which means that essentially what that means is that this is const. So if I wanted to output this to the output stream, for instance, then this will not work unless I say that this is a const book array, because this is a, you know, this is an expression, which means it returns an R value, which means I cannot modify whatever is returned here. I can assign it to something else and then I'll copy it into that other object, but I can't make changes to this. I can't say, you know, what do we have here? We don't have any operations. I can't do this equals new book. So this is, it's what's called an R value, and R values are const. Can't make changes to them, which means that this will only work if we make this const, essentially. There are plenty of other ways that const comes back to haunt you, right? If you're trying to call a non-const function from a const function, of course, you're not allowed to do that. So, you know, you have to be careful which functions you make const, and there's this cascading effect where if my function relies on another function and my function is const, then that other function has to be const as well. Right? It sort of propagates. But when I make a const function, that means that function can be used in a regular function or a const function. So by, making things const, you make them, you give them a broader category of, they can be used more broadly. Anyway, hopefully that clears something. So, yeah. I mean, what happens is you write code, there's some error, you eventually figure it out because you didn't make something const, and that's how a lot of this stuff is actually learned, right? I try to point you in the right direction, but experience is the best teacher. Yes. All right. Other questions? Okay, I don't want to implement that right now. So we're going to implement the double equals, the assignment, and the subscript operator. And we're going to cheat a little bit. So what is this? I have an error somewhere. Oh yeah. Okay. All right, so this is my book array implementation. So we will make a constructor. So yes, we can't have a capacity of less than 0. So we do a little bit of basic error checking. And then we set capacity equal to C, and elements equals new book capacity. All right. Is this going to come back to haunt us? Yeah. So we're implementing this a little bit differently. So this is just a book array. Yeah. So book has a default constructor. So when we first make the book array, whatever the capacity is, each of those book objects will have a default book in it. And then we can use the assignment operator to change that default book. Right, so very quickly, our book array has, so yeah, this is our book array. This is the heap. We have a pointer to an object, an array on the heap, and each of these has a book object in it. But in the beginning, these are the default book objects. So each of them will get initialized. And then we're going to assign different books to them. So this is a slightly different data structure than we're used to, or that you've been building this whole time, but just to give you an overview of what we're doing. Okay. So what else do we need? We need a destructor. Since we do have dynamic memory, we really should, not book array. And in there we can delete. Nice thing about the nice thing about deleting the entire array, since it's an array of objects, all those objects have their destructors called automatically. So I don't have to cycle over this array and delete everything. That would actually cause an error. And then we should implement the rule of 3, but I'm not going to in the interests of time. Okay, let's see here. We want this equals operator. So 2 book arrays are equal if all of their elements are equal and they have the same capacity. So we can say if, and we should really, that can be const and that can be const. So there's nothing being changed in here. So let's, Let's do this properly. Okay. So if, yes, so capacity, if they have different capacities, then they're definitely not equal. So we can say, if they're not, these are not equal, we will return false. And then we will say, then we have to check every single element. So int I equals 0, less than capacity. So again, we can check to see if every element's true, or we can check to see if they're not equal. And then if they're not equal, we'll simply return false right away. And then we can do that efficiently. So yeah, I is not equal to all right, is that okay? Yep, good. And then otherwise, if we manage to get through this entire thing, we can yeah, we can return true. Okay, so for yeah, if we make our own data structure, then this, you know, equals operation, this checking to see if my book array is exactly equal to another book array is a little more complicated, right? We have to check every single element. And this not equals operator, of course, is the not equals operator from our book class. All right. Questions so far? Okay. The assignment operator. So we want to take one book array and make the other book array equal to it. So I'm assigning all of the values in this to, and I'm not changing any of them, so I can make that const as well. All right, so again, yeah, so we're going to check. So if the first thing we could check to see is if this is equal to, if they're exactly the same object, then I'm just going to return this, right? So I'm checking, this is a pointer, so this is a memory address. I'm saying if this memory address is the same as this memory address, then I don't need to do anything. They're already you know, I'm comparing, I'm trying to assign myself to myself, essentially. So I can just exit at that point. Now we have two cases based on the capacity. So if we have different capacities, then I have to delete my book array, my elements array, and make a new one, and then reassign everything. So if capacity is not equal to, then I'm going to delete elements, and then say elements equals new book of capacity, and I'll say capacity all right. Okay. So there, I've deleted the old array. I've made a new one of the correct capacity, and I've initialized this capacity variable, and then I can just copy everything over in a for loop. It's using the magic of copying and pasting, which doesn't actually observe the formatting, but yeah, I loop over every element, and every element from my array, I assign to the proper index in my elements array. And then I'm going to, yeah, enable cascading. So I want to return this. Okay, so fundamentally, these operators are doing essentially the same operations that we've seen before, except, when we're talking about collections classes, they're a little more complicated. But yeah, questions so far? All right. Finally, the operator. Here, I'm going to copy the O stream. Yeah. So we, of course, overloaded this O stream. It's inaccessible, yeah. This should be const. Okay, so we take the output stream, we put a blank line, we iterate over all of the books in our book array, and we output them to the output stream. We put another blank line, and then we enable cascading by returning the O stream. All right, and then, yeah, finally this. Okay, so to overload the, what did I do here? Did I make it const? Oh, I did. Yeah, so you can do this. You don't have to. So again, for some of them, it depends on the, it depends on how we're implementing them. So I do want to be able to grab an object out of my book array and make changes to it. Does every O stream second parameter be const? I can't think of a, unless for some reason, when you sent it to the output stream, you changed that object for some reason. But in general, you don't do that, right? You're simply trying to output the current object. So yeah, it's a good rule of thumb. Again, so you're talking about the second parameter of the overloaded stream insertion operator. As a rule of thumb, should always be const. There might be situations where that doesn't, there's always an exception, but yeah, it's a pretty good rule. Yeah, so what he's referring to is this. So the second argument, I'm almost never going to make changes to this, so I should always make it const. And then it can be, if this happens, if I try to print out an R value, then this will work. Okay. Other questions? Okay, so here, I've made sure that the index was something valid. So if it's less than 0 or greater than the capacity, I'm just going to crash. I'm going to say invalid index, exit 1. Otherwise, I'm going to return a reference to a book. So I'm going to return, so the, sorry, this should be index. So index, whoever called this asked for the book at index. So I'm going to return that book to them by reference. Good, yeah, simple enough. Questions on that? Okay, I believe, did we do everything? Yeah. Okay. Double equals, assignment, and subscript. So now I should be able to, again, this is going to return, if I had made this const, which I almost did there. If I had made this const, the problem is this would not have worked, right? Because if, anyway, we'll try it in a second, but yeah. For now, let's take the first array. We're going to set each of these to, set the first 4 locations to B1, B2, B3, B4, and then we're going to output that array to the output stream. Okay, so the 4 books that we assigned: Ender's Game, Dune, Foundation, Hitchhiker's Guide to the Galaxy. And then there are, since this was initialized to a size of 7, 3 of the books are still uninitialized or initialized with default values. All right. So yeah, in your assignment, you might be tempted to do this, and it would actually work in that assignment, I think, just simply because of the way we do it. Actually, first of all, you might be tempted to make this const. So what's the problem with that is oh, it's gonna, I think we fooled the compiler here. Well, let's try it. Yeah, okay. So we fooled the compiler. But I think if you try this on your assignment, it's going to, it's not going to let you do that. It's going to make you do this. And if you do this, so you'll have to return whatever it is by reference. You'll have to return it by const reference. And that'll work because we don't do any of this in our assignment. But if I return a constant reference, that means I can't change it. Right? So then this assignment operation won't work because this is returning a constant book, which means I'm not allowed to modify it. So yeah, just you know, maybe you haven't gotten there in the assignment yet, so this makes absolutely 0 sense to you. But yeah, just in general, this, if you overload this subscript operator, you do not want to make this constant, because that'll force you to make this constant, which will force you to, then you won't be able to do that operation. Okay, let's try some more stuff. All right, so now we're going to assign we're going to make array 2 equal to array 1. And then yeah, let's actually print out array 2. Okay, and then yeah, we can check to see if they're equal. So we're using this inline, you know, branching operator, conditional operator to return yes or no based on whether these are equal or not. Okay, so array 1 looks like this. We do the assignment operation, then array 2 looks exactly the same. And then are these arrays equal? Yes. All right. Now we can change array 2 by setting you know, book number 2 to B5. So long and thanks for all the fish. And then we're going to check to see if these arrays are equal again. Okay, so in the first case, are they equal? Yes. We change the second. We probably should array 1 and array 2. So just to make the example slightly more clear. So are the arrays equal? Yes. Then we print out array 1. array 2 is now so long and thanks for all the fish is replaced foundation. So are they equal now? And the answer is no. All right, so we're combining a lot of stuff here. Yeah, I guess we could have just uncommented that, but all right. Yeah, questions on this example? Right. And you could implement plus equals and things like that. Again, they're going to be slightly more complex because you have to check the capacity and you'll have to make a new one with a new capacity that's double or this capacity plus this capacity, and then copy all of these into the new locations. But it can be done. All right. That example took longer than I thought. Okay. Yes. So important, if we don't implement this assignment operator in this case, it's going to do a member-wise assignment. It's just going to copy, it's going to do a shallow copy. So if we look back at our example, if I didn't overload that assignment operator and I had book array 2 here, it would point to the exact same books and the exact same, not just the exact same books, but the exact same array on the heap. So by overloading the assignment operator, we made a new array and copied all of these books over. Yeah, so, yeah. All right. So the increment and decrement operators. So if you recall, we can write something like I plus plus or plus plus I or J or minus minus I minus J minus minus. So we can do all of those things. So there's lots of variation. So we have increment or decrement. There is prefix or postfix. And we can make these global or member functions, right? So each of them has their own syntax. So prefix plus plus or minus minus modifies the operand and then returns a reference to the updated object, right? So we want to, again, we're enabling cascading. So after we increment, this increments my I variable. And once it's done incrementing, it should return a reference to this I variable so that we could say, J is equal to plus plus I, and that will work. So if we implement plus plus as a member function, then there are no parameters, right? This is a unary operator. So it only has one parameter, but it's this in this case. This would be the only operand. If it's a global function, then it takes one parameter, which is the object to be modified. Okay, so let's look at example 8. Okay, so we have again our time class. We have an assignment operator, set time, hours, minutes, and seconds. And we've overloaded the output stream operator, and yeah, so we've seen all this before. Nothing new there. In our example, we make an integer, and then we test out all of the different increment and decrement operations on that integer. Right, so yeah, let's run it and then take a look at that. Okay, so the original int is 10. When we send the prefix, the prefix increment operator to the output stream, well, it changes this and then returns it the value and sends it to the output stream. So in this case, both of these values should print out the same thing, which is 10 plus 1, essentially. In the next part, we have a prefix prefix decrement, so it's the same thing. This 10 is modified first, and then the returned so that it can be output to the output stream. And again, both of these should print out the same value. The postfix is a little bit different. Here, it returns the value that was originally in 10 and then modifies it. So it's a little bit trickier, and we'll see how that translates into when we overload that function. But in this case, first we return 10, and then this is changed. So these are going to output different numbers, and the same with the postfix decrement operator. So this will be first, the value that's currently in 10 will be returned. Well, not first, but the value that's the 10 is decremented, and the value that used to be in 10 is returned. And then these will be different as well, which we can see here. Right, so returns the value 10, and then it increments it, and then we print out the new value in 10. And then here, yeah, same thing, except decremented. All right. Good. So everybody's clear on how these prefix and postfix operators work. Okay. Now we want to be able to do the same thing with the time. So yeah, we want to be able to use the prefix plus on the time object. So now plus 1 second, or maybe we'll make it a minute. But all right. So first we will overload these as member functions, and then for the decrement we'll overload them as global functions. Okay, so again, we want to return a reference to a time object. We want to implement this plus. Since this is a member function, and this is a unary operator, there are no arguments, right? So the argument is this, this variable. So that's implicitly passed along. Okay. And this is, by the way, the prefix. Right, since it's not exactly clear what the difference between the prefix and the postfix is, but this is the prefix operator. Okay, and yeah, return a time reference. Okay, so what do we want to do? We want to add 1 second to the time, or 1 minute even. Let's say add 1 minute. So simple enough. We'll say that we'll convert it to seconds. We will add 60 seconds. And then we will set time to this time variable. Yeah. Okay, so simple enough. And then return a reference to this. Okay, good. Questions on this? All pretty clear. Okay, so now it looks like my prefix operator should be working. So these, if we go by the example with the integers, so these should read both the same. So now, plus now, and now should print out the same thing. All right, so the original time is 16:14. We add 1 minute. And yeah, with the prefix operator, both of these print out the same. So we change it, then we return it, and that value gets sent to the output stream. All right. Okay, questions on that? All right, so now we want to do We're going to do the decrement operator, but we're going to implement this as a global function, just to sort of give you the difference. So we want to make another friend function. This is going to return the same thing. We want to return a reference to a time object, but in this case, we're going to pass it in explicitly. Operator minus minus, and then yeah. All right, so this should not be const because we're actually going to change it and then return it. All right, and then of course in our source file we put so we want to add 1 minute to t, or sorry, subtract 1 minute to t. So we could say, yeah, we should do some error checking, but let's say int time equals t dot convert to seconds. Since it's a friend function, we could do that and then subtract 60. Now we should check that, I guess we could check if time is less than 0, time equals 0. And then set time. And now we want to return, in this case, oh yeah, t dot set time, since this is a global function. Now we want to return, normally we would return this, but in this case, since it's global, we've passed in, this is our, in some sense, this. So we return t. All right, so we took this time object, we modified it, we returned it. And then if we look at our main, of course, this is no longer complaining. These should print out the same things. So I'm changing the object and then sending it to the output stream. Okay, so with a prefix decrementer, we take 1615 and it becomes 1614. And then, yeah, afterwards, it's still 1614. Okay, so that's, now why you would make that a global function, I'm not, I mean, you could do that for, it might be necessary if you want to add a prefix or postfix operator to something that doesn't have it that you did not make yourself. But then you do not have access to the, you can't make it a friend either. So, but yeah, questions on the global decrement operator? Okay. So that is prefix for both. So now we have this problem, of course, how do we distinguish between prefix and postfix operators, since we only have one argument either way. So it's either no parameters in the member function or one parameter in the global function. So what, what they did is they sent in a dummy parameter. Right, so it's completely useless. It's just part of the function signature. Again, you saw how the compiler mangles these function names. And this is basically how to distinguish between a pre and postfix operator. And yeah, it seems like a little bit of yeah, a weird solution, but hey, I guess it works. However, postfix is more complicated, right? So we want to, so not only is the signature different, but we have to make a copy of the current object in its unmodified state. And that's what we're going to return. And that will not be a reference, right? So the same as when we, with our plus operator, we made a temporary object and then returned it, returned by value. We're going to do the same thing here. So we are going to need a copy constructor, you know, if you have dynamic memory, you need a copy constructor. However, you know, the default copy constructor might be just fine. All right, so we talked a little bit about how plus plus I is more efficient than I plus plus. And the reason is that because we have to create that temporary object and return it, and possibly actually even, call a copy constructor, this is way less efficient. Well, way less efficient. You will never notice the difference, but if I ran a million of these and a million of these, then you might start noticing the difference. All right, so yeah, if you're trying to write efficient code, you always want to use prefix where possible, particularly with objects, because creating objects can be, create a lot of extra work. All right, let's go back here and implement now our plus plus operator, or yeah, our postfix plus plus and our postfix minus minus. So for now, we will just do plus plus. So we will again implement plus plus as a member function. Yeah, I mean, I really thought we were getting to templates today, but I guess not. Okay, so functionally it's the same. No, sorry. Functionally, we want to return a copy. So it's going to be returned by value. The function signature is the same, but now we're going to tell it, hey, this is a postfix operator. Oh my goodness. Postfix. So we send in the dummy int. Yeah, and we want to return a copy of an object. All right. Let's see, I did want to put it, well, whatever, we'll just put it at the bottom, it's fine. Okay, so we're returning a time object. This is a member function, and there's an int parameter. We don't need to name it. It's a dummy parameter. In fact, I'm not sure what would happen if we tried to use it. It might let us use it actually, but we can try that later. Okay, so we want to make a temporary time object that is time, pass in this. Right, so I'm going to implicitly call this copy constructor, which should be fine. We did not implement one, but the default one should be fine. It's just member-wise assignment. All right. Okay, so we made a new time object with the current time, and then we're going to, well, we could cheat and actually call on this function to do the work for us. Sure, let's do that. So plus plus. Now, if I wanted to make this as efficient as possible, I would not do this, but this will work, right? So this is, we still want to increment this object. It returns something, it returns a reference, we just throw it away. This is not that efficient, but functionally, it's the same as what we want to do. And then at this point, we're going to return time, our temporary object. So we made a copy of this, we incremented this, and then we returned the copy that had the original time. If you had dynamic memory here, you would have to make sure that your copy constructor is properly implemented. But yeah, all right. Why the dummy int is needed? Yes, I can. So what happens is this tells the compiler which of these it is, right? So here I have basically the same function signature, and essentially the return type is not part of the function signature. So what happens is the compiler in order for the compiler to know which of these functions to call when I write ++I or ++time, since these have the same function signature, it would not be able to tell them apart unless I did something to differentiate them, which in this case is have the dummy parameter. So this tells the compiler that this is the postfix version and that this is the prefix version. That's all, because they have the exact same name. Now, why they didn't do something like, add a P to one of them, something like that, I don't know. This seems like a weird solution, but does that make sense? All right. Okay, so we implemented it, so this should work now, this postfix. Okay, so postfix, it returns the original and it increments the new, with the new value, and then when we print out now the second time, it gives us the updated value. So this is exactly how we wanted it to work, is the same as the ints. All right. The last one, we're going to do the postfix, the same thing with the minus operation, but it's going to be a global function. So we're going to here oops, oh my goodness, operator minus. Now we want to have a dummy parameter. So the time object comes first, and then this int so the second parameter is the dummy parameter. All right, and then to implement that, sorry, I'm just sorry. Yeah, for some reason, what I was seeing did not make sense for a brief second. That's all the pain medication I'm on. All right. So yeah, this is our decrement operator, but now this means that it's postfix. So we basically want to do the same things. We're going to make a time. And then now we're going to pass in this T to the copy constructor. So that's going to make a copy of this time object. And then we can do, of course, again, we can cheat a little bit and say minus T. And then we can return time. Right? So we make a copy, decrement it, and then return the copy with the original time. All right. Yeah. So now these two, the two values, the times that we print out should be different. All right. So with the postfix decrement operator, we return the original time, and then when we print out the new and improved time, it's decremented. All right. So those are your pre and postfix operators. I can't believe how long that took. All right. Any questions? It is a shallow copy. So we didn't bother making a copy constructor simply because these are all primitives. Well, not that they're primitives, they're statically allocated. Right. So all of these are stored with the object. So the default copy constructor works fine for this purpose. Yeah. what's the point on making a copy of the object? So we want to, because we want to return the old time. So this postfix operator, right? When we, so we're calling, yeah, postfix increment. So the time object that we passed in is actually incremented to 1615. But we want to return this old time object because that's, well, that's the behavior, right? So when I say now plus plus, what I'm saying is print out whatever this value currently is and then increment it. But, that's not, so when I say it that way, it sounds different. I say, okay, first I print this and then I increment it. But actually what happens is that I make a copy of this and then I increment the original and then I return the copy. Yeah. So that is the expected behavior of the postfix. All right. Time to do this last example, I'm not sure. All right, so yeah, the dummy int is the difference between the prefix and postfix versions of these plus plus and minus minus operators. Global functions take two parameters, the reference to the operand and the dummy int. If it's a member function, it just takes the dummy int as a parameter. We could fool around and try and see if that int actually has a value, but we'll leave it for today. Maybe we'll leave this for next class, but let's try. So if we overload this stream insertion operator for an inherited class, so this is a global function, and what if we want a polymorphic example of this, right? So we can't implement polymorphism with a global function. So solution one, we can make a separate function for each derived class. Of course, this is not the most efficient thing to do. But solution two is we can use a layer of abstraction. So if we make a print function that takes an O stream as an argument, and then we can implement that as usual, but instead of cout, we use OS. And then we can implement this as a global function, and then the parameter is of the base class, right? So this is our old barnyard example where animal is the base class. I believe it's even anyway. We probably don't have time to do it. Maybe we'll save that for next class. I don't want to rush through this because it is sort of important. Boy, that all took longer than I thought. So yeah, next class we will see how to instead of making a separate, a separate global function for each time I want to overload. Each time I make a new child of this animal class, I have to make a new separate function, or I can, use a little black magic and have this same global function work for all of my derived classes. But all right. But that's it for today. I can stick around to answer some questions. But otherwise, yeah, that's it. I guess this is Wednesday. This is B class. So yeah, have a good weekend and see you next week.